The solar system is a pretty big place. When most people think of our solar system, they probably think of the sun, the planets, and all their moons. However, the solar system is much larger than most people realize. In fact, it's vastly larger than the model of the solar system that they have in their head. In only the last few years, with the advent of larger telescopes and better techniques, we have been able to learn more about the outer edge of our solar system than ever before. Learn more about the Kuiper Belt, the Oort Cloud, and the outer reaches of the solar system on this episode of Everything Everywhere Daily.
The NBA playoffs are here, and I'm getting my bets in on FanDuel. Talk to me, Chuck GPT. What do you know?
All sorts of interesting stuff, even Charles Barkley's greatest fear.
Hey, nobody needs to know that.
New customers bet $5 to get $250 in bonus bets if you win. FanDuel, America's #1 sportsbook.
21 plus and present in Virginia. Must be first online real money wager. $5 deposit required. Bonus issued as non-withdrawable bonus bets that expire 7 days after receipt. Restrictions apply. See full terms at FanDuel.com/sportsbook. Gambling problem? Call 1-800-GAMBLER.
The spirit of innovation is deeply ingrained in America, and Google is helping Americans innovate in ways both big and small. The Department of Defense is working with Google to help secure America's digital defense systems, from establishing cloud-based zero-trust solutions to deploying the latest AI technology. This is a new era of American innovation. Find out more at g.co/American innovation.
In previous episodes, I've covered most of the highlights of the solar system. I've done episodes on the sun, every planet, the moon, Pluto, and the asteroid belt. The only thing I haven't done one on is the Earth, and in a way, you can pretty much think of every other episode I've done as being about the Earth. If you were to ask what the solar system consists of, most people would probably just list those things. However, to paraphrase the late great Mitch Hedberg, there's a lot more to it than that. The solar system is technically defined as the region that is gravitationally bound to the sun. Thus, it includes all the planets, asteroids, meteoroids, comets, and other familiar objects. But this episode is about the other stuff. And there is a lot of other stuff. Let's start with our current understanding of solar system formation. Not just our solar system, but a model that can be used for any solar system. Our understanding of solar system formation has expanded significantly in the last few years due to observations made by instruments such as the James Webb Space Telescope. The current theory of how the solar system is formed is known as the nebular hypothesis, and it's supported by extensive astronomical observations, physics, and computer simulations. According to this theory, the solar system began forming about 4.6 billion years ago from a vast, cold cloud of interstellar gas and dust known as a molecular cloud. Within this cloud, a small region became gravitationally unstable, possibly triggered by a nearby supernova shockwave or some internal fluctuation, and it began to collapse on itself under its own gravity. As it collapsed, conservation of angular momentum caused it to spin faster and flatten into a rotating disk of material. This disk is known as a protoplanetary disk, and it played a central role in the formation of the sun and the planets. At the center of the protoplanetary disk, matter accumulated to form a dense core. As more material fell in, pressure and temperature increased until nuclear fusion of hydrogen atoms began in the core, marking the birth of the proto-sun. Once fusion was fully underway, the sun became a main sequence star, radiating energy and generating a powerful solar wind. While the sun formed in the center, the surrounding disk of gas and dust spinning around it served as the nursery for the formation of planets, moons, asteroids, and comets. Within this disk, small particles of dust and ice began to stick together through electrostatic forces, forming larger grains. These grains continued colliding and sticking together to form larger and larger clumps, eventually growing into kilometer-sized bodies called planetesimals. These planetesimals, through a process of accretion, continued to merge due to gravity, forming larger bodies known as protoplanets. Temperature played a crucial role in determining the type of materials that could condense at different distances from the sun. In the inner region of the disk, closer to the sun, temperatures were too high for volatile compounds like water, methane, and ammonia to condense. As a result, only metals and silicate rocks remain solid, which is why the terrestrial planets, Mercury, Venus, Earth, and Mars, are composed primarily of rock and metal. In the outer regions, where the disk was cooler, ices could condense along with rock, allowing the formation of larger solid cores. These cores grew massive enough to gravitationally attract large envelopes of hydrogen and helium gas, forming the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Neptune is important in this story because this episode concerns everything beyond Neptune's orbit, which are collectively known as trans-Neptunian objects. The concept of a distant region beyond Neptune containing small icy bodies dates back to the mid-20th century, although ideas leading to it go back even further. In 1943, Irish astronomer Kenneth Edgeworth suggested that the solar system might not abruptly end at Neptune, proposing instead that a reservoir of small bodies likely existed in the outer reaches, possibly the source of some comets. A few years later, in 1951, the Dutch-American astronomer Gerhard Kuiper proposed that a disk of icy remnants could have once existed beyond Neptune, although he believed these objects would have been scattered or ejected by planetary interactions over time, and thus no longer existed in the present-day solar system. Despite Kuiper's belief that such a belt would no longer exist, his name became associated with the idea, and the term Kuiper Belt gradually gained popularity. One reason astronomers thought the Kuiper Belt existed was periodic comets, which had an orbit of less than 200 years and were observable at regular periods in history. The most famous of these regular comets is Halley's Comet. The Kuiper Belt begins at the orbit of Neptune, which is approximately 30 AU, or astronomical units from the Sun. An astronomical unit is the average distance from the Earth to the Sun, and it's the primary unit used for measuring distances within the solar system. The Kuiper Belt extends out to a distance of about 55 AU and has a thickness of about 10 AU, so it's shaped more like a donut rather than being on the ecliptic plane. The Kuiper Belt is composed mainly of icy bodies and frozen volatiles such as methane, ammonia, and water, but it also contains some rocky debris left over from the formation of the solar system. The most famous object in the Kuiper Belt is Pluto. However, there are many others that have been discovered. Albion, Haumea, and Makemake are some of the larger objects that have been discovered. There are thousands of Kuiper Belt objects that have already been discovered since the development of astrophotography made it easy to see if small objects are moving across the sky over time. It's estimated that there may be over 100,000 objects, over 100 kilometers, or 62 miles in diameter. What many of these closer Kuiper Belt objects have in common is that they are gravitationally influenced by Neptune, like Pluto. There has been one spacecraft that has made a flyby of Kuiper Belt objects. The New Horizon mission flew past Pluto in 2015 and later took a photo of the object known as Arrokoth in 2018. Arrokoth basically looks like a large space potato. Beyond the Kuiper Belt, beginning at around 50 AU, is a region known as the scattered disk. The scattered disk is a distant and dynamic region of the solar system that overlaps with and extends beyond the Kuiper Belt. It's filled with icy objects known as scattered disk objects, which have highly elongated and inclined orbits. The scattered disk gets its name from the fact that heavier objects like Neptune scattered the objects that are in this region. The two most notable discoveries from this region are Eris, the second most massive dwarf planet after Pluto, and Sedna, which has an extremely long and eccentric orbit. The scattered disk extends out to approximately 1,000 astronomical units. Because of the highly inclined orbits of objects in this zone, it is even thicker than the Kuiper Belt. This region contains the heliopause, which is the boundary around the Sun where the interstellar wind cancels out the solar wind. It's located at approximately 123 astronomical units from the Sun, and it has been passed by both Voyager 1 and Voyager 2 spacecrafts. The outer boundary of the scattered disk is really far away. At 1,000 astronomical units, it takes light from the Sun 138 hours to get there, or a little under 5.5 days. However, it is not the furthest region of the solar system. That distinction belongs to a theoretical region known as the Oort Cloud. The Oort Cloud extends from approximately 2,000 to 100,000 astronomical units. And it also isn't a disk like the Kuiper Belt, which lies roughly around the ecliptic plane. It's a sphere around the entire solar system. The Oort Cloud theory was developed to explain the origin of long-period comets, which have highly eccentric orbits and take hundreds of thousands or even millions of years to return to the inner solar system. In 1950, Dutch astronomer Jan Oort proposed the idea on a detailed analysis of the orbital characteristics of comets. He noted that many long-period comets seem to arrive from all directions, not confined to the solar system's plane, and that the points in their orbits farthest from the Sun clustered at vast distances. The distribution suggested a spherical reservoir of icy bodies surrounding the solar system far beyond the planets. It's also believed that there is an inner disk known as the Hills Cloud, which is a hypothetical interior region of the Oort Cloud, lying between approximately 2,000 and 20,000 astronomical units from the Sun. It's thought to be more densely populated than the outer Oort Cloud and may act as a reservoir that replenishes over time. So why have thousands of objects been discovered in the Kuiper Belt, but the Oort Cloud remains theoretical? The Oort Cloud remains theoretical because it has never been directly observed. Its immense distance from the Sun places it far beyond the reach of current telescopes and spacecraft. Objects within the Oort Cloud are expected to be small, icy, and very faint, reflecting little sunlight, making them nearly impossible to detect individually with existing technology. The Oort Cloud is believed to be composed mainly of icy planetesimals, small bodies made of water ice, ammonia, and methane, and rock left over from the formation of the solar system. These objects likely formed much closer to the Sun in the region near Jupiter and Saturn, but were gravitationally scattered to the outer solar system by interactions with the giant planets during the chaotic early stages of planetary formation. Over time, these scattered bodies settled into the distant spherical distribution we now associate with the Oort Cloud. Objects in the Oort Cloud are usually stable and remain far from the Sun, but occasionally the gravitational pull of passing stars, molecular clouds, or the tidal forces from the Milky Way galaxy can perturb their orbits. These disruptions may send some of the objects hurtling towards the inner solar system, where they appear as long-period comets. Because these comets come from such vast distances, their visits are very rare, and they often have highly elongated and unpredictable orbits. Because of the enormous size of the Oort Cloud, it is estimated to have over 1 trillion objects larger than 1 kilometer in diameter. So, is there anything in the solar system beyond the Oort Cloud? And the answer to that is easy. No. And the reason is that the outer limit of the Oort Cloud is the limit where the Sun's gravity has influence. At the outer edge of the Oort Cloud, approximately 100,000 astronomical units from the Sun, it takes light from the Sun over 1.5 years to reach. Beyond that point, the gravity from nearby stars or the rest of the galaxy begins to have more sway. So, by definition, that is no longer part of the solar system. The outer edge of the Oort Cloud is a little under half the distance to our closest neighboring star, Proxima Centauri. So, if there was some galactic empire, that would probably be where they would draw the border of our solar system. The takeaway from all of this is that our solar system is much bigger than most people think it is. Our mental model of the solar system is a bunch of concentric rings representing the orbits of the planets. And regardless whether you think of Neptune or Pluto as the furthest planet, that distance is tiny compared to the size of the Oort Cloud. The average distance of the orbit of Neptune is about 30 astronomical units, and Pluto is about 40, whereas the outer edge of the Oort Cloud would be 100,000. The icy objects on the edge of the solar system might not be very interesting, and in many cases even impossible to observe, but they are still all part of our solar system family. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oken and Cameron Kiefer. Before I get to the review, I have a correction to make. In the episode on the history of the guitar, I had several people notify me that one of the early predecessors of the guitar that I mentioned was pronounced incorrectly. The Middle Eastern instrument pronounced O-U-D, I called an oud, and it should be pronounced oud. I kind of made a similar error years ago when I went to a restaurant in Cairo and there was a dish on the menu spelt F-O-U-L, and I pronounced it foul because it was spelt the same as foul ball. However, it turned out to be pronounced fool. So, mea culpa, mea maxima culpa. And with that, today's review comes from listener Montana123 Matt over on Apple Podcasts in the United States. They write, "Complete from Montana. This podcast is amazing. Gary has a good voice and the crazy stuff I've learned listening to him has been very entertaining." Well, thanks, Matt. First, congratulations and welcome to the Completionist Club. It is always nice to see the Big Sky State representing. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.